Hi guys, this is Mrs. Gastler, and in this video we're going to talk about wave interference. It's actually a pretty cool thing and has a lot of applications in real life that I've actually studied doing some research when I was in graduate school. It was pretty cool. So let's get started here. So interference is a pretty cool thing. It happens when two waves or more, could be more, are at the same place at the same time in like physical space. So they're literally like right over there at the same time, at the same place, okay? And when that happens, the waves interact and they either will add or subtract from each other. And when that happens, some cool stuff can take place. So if it's a sound wave, they'll either sound louder or they'll sound softer. You've seen some applications of this if you have ever used noise-canceling headphones that are active noise control. What active noise control headphones do is they hear a sound and then they produce a sound to cancel it out, so that they subtract from the sound so that it's softer where your ears are. That's actually really cool that happens. You might not have seen what happens when light waves interfere. They get brighter or they get darker. That one is less obvious to notice, but it's still really cool when it happens. We might get to see some of that in class. We'll see. Now, there's two ways that we describe the interference, and it actually goes with the whole adding and subtracting business that we just talked about right there. And they either are constructive interference or destructive interference. And so we're going to talk about those together here. So let's talk about constructive interference first. When you have constructive interference, that's when they add constructive. You might think about constructing things. That means that they're going to get bigger when the waves get together. They're going to add together to get bigger. And so we have an example here where we take this wave that is one high. We're just going to be looking at some square waves for our examples here. And we're gonna have this other wave that is also a square wave. And when these two waves come together and they're in the same place at the same time, what do you think is going to happen? Well, if this is what you were expecting to see, then you are correct. So you have your 1 and your 2, and you get them together in the same place, and you get 3. That shouldn't be too surprising. That is constructive interference. They're getting bigger when they are together in the same place. Now, those waves might be coming toward each other, or they might be going, some weird angle, but they end up in the same place at the same time. They get bigger. Now, destructive interference is the opposite of that, so that's when they subtract. And this one's kind of weird. We're still going to write it as if we're adding, but what happens is that the waves are going to get smaller when we put them together. So the resulting wave is going to be smaller. So we're going to take our same wave again, but this time we're going to add this wave to it. And it's upside down. You see, it's kind of like it's a negative 2. It's a hole in the ground instead. So when we put those waves together at the same spot, we get this wave that is smaller. It's smaller than the original. It's lower. It's a smaller wave. So this is destructive interference. So this might help you think about why it might be louder or brighter or dimmer or darker or softer when you have constructive or destructive interference. So this idea here where we're just adding the waves or subtracting the waves to see what the resulting wave is actually called the principle of superposition. And that's how you figure out what the resulting wave is going to be. And so we're going to write out the principle of superposition here. It says when two waves are at the same point, the displacement of the resulting wave is the sum of the individual waves. That's the fancy way of saying add them up, okay? So in other words, add them or subtract them like they are numbers, okay? And so now we have a bunch of practice that we're going to do here. And we've got our first example is very similar to the first one that we did. We have a 1 wave and a 2 wave. And when they meet, what do you think they're going to make? Well, if you were guessing a 2 wave, then you're right. So is that going to be constructive or destructive interference? Well, it looks like they're getting bigger. Okay, so this 2 is definitely bigger than both of those original waves, and so it is constructive interference. So let's look at another example. So now we have a 1 plus a 2. And what is that wave going to look like when they meet? Well, that's going to be, I got an extra little blob there. We've got a 3 there. That wave is definitely bigger than the original 2 waves that we have. What is that kind of interference? If you said constructive, you are right again. And now I've got my third example. Now I have a 1 and a -1. That -1 is down on the bottom. I put a negative there because it's like a hole in the ground, okay? And when those waves meet, this one's a fun one. What are you going to write in that what they will become box? Well, if you drew a flat line, you are right. Those cancel completely out. If this were sound, you would hear absolutely nothing. And if this were light, you would see absolutely nothing. Okay, this is something that cancels completely out. This is definitely destructive interference. There's nothing left after that. Okay. For our fourth example, now we have a 1 and a -2. This is the one that we did in the previous one, so you already know the answer to that one is -1. And this was our example for destructive interference, so you know that one is destructive. And what do you think about this one? This one might be kind of hard. So we've got a -1 and a -2. And if you guessed that this one is a -3, then you are right. But is this one constructive or destructive? Is it getting bigger or is it getting smaller? And how do you know? So we have to think about this one in terms of amplitude. Amplitude, remember, is how big it is or how far the maximum displacement it gets from that equilibrium position, that middle line. So we've got the line here. This line right here is the middle line. So it's getting farther from that line. This wave is actually getting bigger. So this is definitely constructive interference. It is getting more negative, but it's a bigger number. So we have 1 and 2, and now we have 3. This one and this one are very similar. It's just getting farther down instead of farther up, but it's still constructive interference because it is a bigger amplitude. Okay, it's about the amplitude. So in your packet up next, you'll have some practice to try. These are actually kind of fun, where you have to put those waves together and see what they meet. There is a website linked in Schoology for you to play with, so that you can actually try those and watch them come together and pass each other up. It's really entertaining to watch waves interfere with each other. If you have any questions, make sure you ask your teacher. Thanks for watching.